Hello everyone, in the last video we have learned properties of periodic functions. Today I am going to explain Laplace transformation of periodic functions. Then what is periodic function? Periodic function is a function which repeats its values at regular intervals. For example, trigonometric functions like sin theta, cos theta, etc. they repeat at intervals of period 2 pi radian. We will use these periodic functions throughout our science to describe oscillations, waves and other phenomena which exhibits periodicity. Then what is the definition of periodic function? A function is said to be periodic function for the period t greater than 0. Here I have taken t, you can take any non-zero constant. Okay, if f of t plus nt equals f of t. For example, as I said, trigonometric functions sin theta and cos theta are examples of periodic function. For example, sin of t plus 2n t or 2n pi equals sin t, cos of t plus 2n pi equals cos t for n equals 1, 2, 3 etc. If I put n equals 1, we will get sin of t plus 2 pi. What is sin of 360 plus theta? It is sin theta. It comes under first quadrant. So we know ASTC, so 0, first quadrant. It is nothing but sin t. Similarly, cos of t plus, if I put n equals 1, 2, 3, we will get the same result, that is cos t. Therefore, sin t and cos t are examples for periodic function. So we have a graph for sin of t plus 2n pi. What is sine wave? It is 0 to 2 pi. After 2 pi, again it will repeat. It will repeat as I said, a periodic function is a period which repeats its values at regular intervals. So similarly, cos function will starts from here because cos 0 is 1. Then what is Laplace transform of periodic function? See, a periodic function f of t of a period t which is greater than 0, then Laplace of f of t, Laplace transform of periodic function is 1 over 1 minus e power minus s into capital T integral from 0 to t e power minus s into t into f of t into dt. So this is the definition of Laplace transform of periodic function. Here t is the variable and s is the parameter which is always positive. Okay, but in our syllabus we don't have derivation of Laplace transformation of periodic function. So directly I am going to explain few problems based on this property. Okay, first problem. If f of t equals t square for 0 less than t less than 2 and f of t plus 2 equals f of t for t greater than 2, find Laplace of f of t. So we have Laplace of f of t equals, what is the formula to find Laplace transformation of periodic function? It is 1 over 1 minus e power minus s into capital T integral from 0 to capital T e power minus st into f of t into dt, where t is the period. What is the period here? See here, we have f of t plus capital T equals f of t. Remember the definition of periodic function, it is f of t plus nt equals f of t. Then the capital T will be our period. Here in the place of capital T we have 2. Therefore, t equals 2 is the period here. Is the period. Substitute those values. We will get 1 divided by 1 minus e power minus s into 2 capital T. Limit from 0 to t e power minus st into f of t. What is f of t? It is t square into dt, that is 1 over 1 minus e power minus 2s integral from 0 to t t square into e power minus st into dt. Next we need to integrate this. Integration by parts. T square into e power minus st. That is 1 over 1 minus e power minus 2s into. If I apply integration, Bernoulli's integration by parts, we will get first function t square into integration of second function e power minus st divided by minus s. Next, alternative sign, minus differentiation of first function 2 square is 2t. Integration of second function is e power minus st divided by minus s. Already we have minus s here, so this becomes s square. Plus, again differentiate this 2 into, again integrate e power minus st divided by minus s whole cube, limit from 0 to t, 0 to 2, sorry. So give the limits, upper limit 1 over 1 minus e power minus 2s into, if I give upper limit here, minus 1 by s common, take 1 minus 1 by s constant, take it outside. If I put t equals to, it is 4 into e power minus 2s, t square is 4, e power minus 2s, minus lower limit 0 into anything is 0. Next, take 2 by s square, 2 by s square into upper limit 2 into e power minus 2s, minus lower limit is 0, again minus 2 by s cube into upper limit e power minus 2s minus lower limit e power 0 is 1. So if I take 2 by s cube as common, 2 by s cube into 1 over 1 minus e power minus 2s, then will remain with, if I take 2 outside, we'll get minus 2s square into e power minus 2s. So minus again 2 into s into e power minus 2s. So I have taken minus 2 by s cube outside. So minus will remain with minus e power minus 2s plus 1. So the final answer is 2 by s cube into 1 minus e power minus 2s into 1 minus. Here we have e power minus 2s as common. So take e power minus 2s common, will get 2s square plus 2s plus 1. So this is the Laplace transform for the periodic function f of t equals t square. Okay, second problem. Find the Laplace transform for the full wave rectifier f of t equals e sin omega t for 0 less than t less than pi by omega having the period pi by omega. So what is the formula to find the Laplace transformation of periodic function? It is Laplace of f of t equals 1 over 1 minus e power minus s into capital T integral from 0 to t e power minus st into f of t. So what is capital T now? So they have given the period as pi by omega. It is our capital T now. So substitute those values. We'll get 1 over 1 minus e power minus s into pi by omega. Limit from 0 to pi by omega e power minus st into f of t. What is f of t? It is e into sin omega t into dt. So take e outside, it is constant, e power minus s pi by omega integral from 0 to pi by omega e power minus st into sin omega t into dt. Now we need to integrate this. It is in the form of e power, it is in the form of e power ax into sin bx. What is integration of e power ax into sin bx? It is e power ax by a square plus b square, a into sin bx minus b into cos bx. So in the place of a, I have minus s, in the place of b I have omega. So substitute those values. What is the integration now? E divided by 1 over minus s pi by omega into e power minus st divided by a minus s whole square plus b omega square into a into sin bx. What is a? It is minus s into sin omega t minus b omega into cos omega t, limit from 0 to pi by omega. Now apply the upper and lower limits for this. So what is the upper limit? So e divided by 1 minus e power minus s pi by omega into minus s square, it is plus s square plus omega square, it is also constant, take it outside. Now apply the limit, it is e power minus s pi by omega into upper limit minus s into sin omega t. See here, minus s into sin omega, in the place of t up, if I take pi by omega, omega cancel, will remain with sin pi. What is the value of sin pi? It is 0. Similarly, cos of omega pi by omega will get cancelled. What is the value of cos pi? It is minus 1. So I can write this as 0 minus cos pi. If I put pi by omega here, that is cos pi, it is minus 1. Already we have minus, it is plus omega minus lower limit e power 0, it is 1 into sin 0 is 0 minus cos 0 is 1, 1 into omega is omega. So we have minus into minus omega, it is plus omega. So I can take omega outside, will remain with minus into minus plus, it is 1 plus e power minus s pi by omega overall divided by a square plus omega square into 1 minus e power minus s pi by omega. But actually we don't have any formula to solve this. So multiply numerator and denominator by, multiply both numerator and denominator by e power s pi by 2 into omega. S pi by 2 into omega, multiply that, e omega into, if I multiply this, e s pi by 2 into omega plus e power minus, I will get, if I multiply, we have s pi by omega into, if I multiply s pi by 2 omega, then it is s pi by omega plus s pi by 2 omega. If I take s pi by omega as common, will get minus 1 plus 1 by 2. It is minus 1 by 2. Minus 1 plus 1 by 2 is minus 1 by 2. So I can write this as minus s pi by 2 omega overall divided by s square plus omega square into 1 minus e power minus s pi by omega is multiply by s pi by 2 omega. It is s pi by 2 omega minus e power minus s pi by 2 omega. So e omega into, I can write this as, it is in the form of e power theta plus e power minus theta. What is the formula of e power theta plus e power minus theta? It is 2 into cos hyperbolic theta. Similarly, in the denominator, e power theta minus e power minus theta is 2 into sin hyperbolic theta. So 2 will get cancelled, and the final result is e omega cos by sin. It is cot hyperbolic s pi by 2 omega overall divided by s square plus omega square. So this is the result for the periodic function e into sin omega t. Okay, third problem. So they have given f of t equals e for 0 less than t less than a by 2, and for minus a it is a by 2 less than t less than a, where f of t plus a equals f of t, where f of t plus a equals f of t means for this problem we have the period capital T as a, capital T as A, because we have f of t plus A equals f of t. Then show that the Laplace of f of t equals E by S into tan hyperbolic As by 4. So we already know the formula, that is Laplace of f of t equals 1 over 1 minus e power minus st 0 to t e power minus st into f of t into dt. So capital T equals A. Now 1 over 1 minus e power minus s into capital T, it is A. Integral from 0 to A e power minus st into f of t into dt. For this we have 1 over 1 minus e power minus as into 0 to A means we have 0 to A by 2 and A by 2 to A. So for 0 to A by 2, what is f of t? It is E into f of t. So minus s, it is E into e power minus st into dt plus A by 2 to A by 2 to A, again E into e power minus st, it is minus E into e power minus st into dt. So here E is constant, take it outside, I can directly write e power minus st, and this is minus e power minus st into dt. Integrate now. It is E divided by 1 minus e power minus as into integration of this e power minus st divided by minus s, limit from 0 to A by 2, minus again integration of this e power minus st divided by minus s, limit from A by 2 to A. Finally we will get E divided by 1 minus e power minus as, here also we have s, here also we have s, take s outside. Then we remain with actually e power minus st minus 0 to A by 2 minus into minus plus e power minus st for A by 2 to A. Apply the limit. E divided by s into 1 minus e power minus as, upper limit, it is minus e power minus as by 2, in the place of t put A by 2, minus lower limit e power 0 is 1, it is plus 1, plus e power minus as, for lower limit minus e power minus as by 2. So we have E by s into 1 minus e power minus as into, I can write this as 1 minus 2 into e power minus as by 2 plus e power minus as by 2 minus as by 2 minus 2 into as by 2. So this is nothing but E by s 1 minus e power minus as into, it is in the form of a minus b whole square, a square minus 2ab plus b square. What is a? It is 1 minus, what is b? E power minus as by 2 whole square. Expand this, a square is 1 minus 2ab, 2 into 1 into b is e power minus as by 2. What is b square? It is e power minus as. So it is in the form of a minus b whole square. If b is e power minus as by 2, if b is e power minus as by 2, then b square is e power minus as. See here, b square e power minus as, it is nothing but a square, it is 1. It is in the form of a square minus b square. What is a square minus b square? It is a plus b into a minus b. So I can write this as 1 minus e power minus s by 2 whole square into s into a plus b, 1 plus e power minus as by 2 into a minus b, 1 minus e power minus as by 2. 1 as minus by 2, 1 over 1 minus e power minus as by 2 get cancel, e into 1 minus e power minus s by 2 divided by s into 1 plus e power minus as by 2. But in the result we require tan hyperbolic as by 4. Here we have as by 2. So multiply both numerator and denominator by, multiply both numerator and denominator by e power as by 4. We will get e into e power as by 4 minus e power minus as by 4. We did it in the last problem also. Minus 1 by 2 plus 1 by 4 is minus 1 by 4. S into e power as by 4 plus e power minus as by 4. So e by s into 2 into sine hyperbolic e power theta minus e power minus theta. Sine hyperbolic as by 4, 2 into cos hyperbolic as by 4. 2 will get cancelled. So final answer is e by s into tan hyperbolic as by 4. Tan hyperbolic as by 4. So this is the result for the given problem. See here, in this we have taken 1 minus e power minus as a square minus b square. It is nothing but a plus b and a plus b into a minus b. Remember this to solve this problem. Okay. Next problem. See here, we have f of t equals t for 0 less than or equal to t less than or equal to a, 2a minus t for a less than or equal to t less than or equal to 2a, and f of t plus 2a equals f of t. So what is the period here? We have f of t plus 2a. So capital T is 2a. So this is the period. Okay. For that we have two questions. First one, sketch the graph of f of t as a periodic function, and second one is as it is, show that the Laplace of f of t, and find the Laplace of f of t for periodic function. See, for the first one, sketch the graph of f of t as a periodic function means, take y equals f of t. Take y equals f of t. So this is nothing but for the first one, we have y equals t. What is y equals t? Y equals t is nothing but a straight line. If I take this as t axis and this as y axis, so y equals t is nothing but a straight line which passes from the origin with an angle of 45 degrees. So the straight line. Then we have one more, that is y equals 2a minus t. What is y equals 2a minus t? So I will take this t to here, t plus y equals 2a. It is nothing but t divided by 2a, y divided by 2a equals 1. It is in the form of x by a plus y by b equals 1. What is x by a plus y by b equals 1? It is also a straight line with the point a comma 0 and 0 comma a. So here we have t by a plus y by 2, t by 2a plus y by 2a equals 1 is nothing but a straight line with the point 2a comma 0 and 0 comma 2a. So what is the graph now? This is nothing but, if I take this as 2a 0 comma 2a and this as 2a comma 0, so this is nothing but a. So this is our y equals t and this is our y equals 2a minus t. Okay. So this is the required graph for the function y equals t and y equals 2a minus t. If we continue this, we'll get the graph like this, 2a to 4a. So remember the definition of periodic function. A periodic function is a function which repeats its values at regular interval of time. See here, here we have capital T equals 2a. So take 2a for 4a for 6a, will get the graph like this. So this is the required graph for the function f of t equals t and 2a minus t. For the second one, to find the Laplace of f of t, we require Laplace transformation formula. So what is the Laplace transformation formula? It is Laplace of f of t equals 1 over 1 minus e power minus s into capital T, integral from 0 to t, e power minus st into f of t into dt. So we know the value of capital T, it is 2a, since we have f of t plus 2a equals f of t. So substitute those values. We have 1 over minus s into 2a, 0 to 2a, e power minus st into f of t into dt. That is nothing but 1 over 1 minus e power minus 2as into. So 0 to 2a, we have 0 to a and a to 2a. So 0 to a, e power minus st into what is t, f of t, it is t into e power minus st plus. So for a to 2a, it is 2a minus t into e power minus st into dt into dt. So we need to solve this. 1 over 1 minus e power minus 2as into upper limit, integration by parts. Integrate this. T into e power minus st divided by minus s. Minus differentiation of t is 1. Integration of this e power minus st divided by s square. Divided by s square, because already we have minus s. So for the limit 0 to a. Similarly, second one, 2a minus t into integration of this e power minus st divided by minus s. Minus differentiation of this, 2a is 0, minus t is minus 1, e power minus st divided by plus s square for a to 2a. So apply the limit. It is 1 over 1 minus e power minus 2as into minus 1 by s into upper limit. If I put a here, a into e power minus as, minus lower limit, it is 0, because 0 into anything is 0, minus 1 by s square into upper limit e power minus as, minus lower limit, it is minus 1, because e power 0 is 1. Next, minus 1 by s into upper limit. If I put 2a here, 2a minus 2a, 0, minus lower limit, put a here, 2a minus a, it is a into e power minus as. Next, plus 1 by s square into upper limit e power minus 2a s minus lower limit is e power minus as. So minus into minus is plus. Okay, here we have minus 1 by s, a into e power minus as. Here we have minus into minus plus a into e power minus as. This will get cancelled. So we'll remain with now 1 over 1 minus e power minus 2as into, so minus, if I take 1 by s square as common, then we'll remain with minus e power minus as, minus into minus plus 1, next plus e power minus 2as minus e power minus as. 1 over s square into 1 minus e power minus 2as into, it is nothing but 1 minus 2 into e power minus as plus e power minus 2as. So a minus b whole square, like previous problem. It is a is 1, b is e power minus as. So a minus b e power minus as whole square divided by s square into 1 minus e power minus 2as. So 1 minus e power minus as whole square divided by s square into, it is in the form of a square minus b square. It is 1 plus e power minus as, 1 minus e power minus as. 1 minus e power minus as, 1 over e power minus s get cancelled. It is 1 over e power minus as divided by s square into 1 plus e power minus as. So multiply both numerator and denominator by e power as by 2 to get the result. As by 2. Multiply this. We will get 1 by s square into e power as by 2 minus e power minus as by 2, minus 1 plus 1 by 2 divided by e power as by 2 plus e power minus as by 2. It is 1 by s square into 2 into sine hyperbolic as by 2. Sine hyperbolic as by 2. E power theta minus e power minus theta. And it is 2 into cos hyperbolic as by 2. 2 will get cancelled. So we got the result now. It is 1 by s square into tan hyperbolic as by 2. So this is the required result for the problem f of t equals t and 2a minus t. Okay, so far we have done so many problems on Laplace transformation of periodic functions. So these two are assignment problems to you. Try to solve this. F of t equals e sin pi t by omega for 0 less than t less than omega, and f of t plus omega equals f of t. Here the period is capital T equals omega. So you can easily solve this. And for the second one also, f of t equals t pi minus t for 0 less than t less than pi less than t less than 2 pi. So here the period is 2 pi, and also sketch the graph for this problem. Sketch the graph for t 0 less than t less than pi and pi minus t pi less than t less than 2 pi, and hence find its Laplace of f of t, that is Laplace transformation of periodic function. Today we have done some problems on Laplace transformation of periodic functions. In the next video we will going to learn problems on Laplace transformation of unit impulse function.